theorem statement show that two vectors u1 bar and u2 bar in a vector space V, in a vector space V is linearly dependent are linearly dependent if and only if one of the vectors vector is a multiple of other others. So first we are going to prove here necessary part. First of all, we are going to take one example here. So take first example. So say here, take u1 bar is equal to 1 2 and u2 bar is equal to say 4 8. Then u2 bar is equal to these two vectors are linearly dependent, and we can write this u2 bar is equal to 4 times u1 bar, because 4 8 is equal to 4 times 1 2, and therefore these two vectors are linearly dependent. Or we can write u1 bar, or we can write 4 u1 bar minus u2 bar is equal to 0 bar. And this implies, what is the coefficient of u1 bar? That is alpha 1 is equal to 4 and alpha 2 is equal to minus 1. That is scalar. We write the combination alpha 1 u1 bar plus alpha 2 u2 bar, and alpha 1 and alpha 2 are not equal to 0, and therefore they are linearly dependent by using definition. So we want to prove this. So what is given here? Given, first we are going to prove here necessary part. So given u1 bar and u2 bar are linearly dependent. And what is our claim here? We want to prove that claim is one of the vector is multiple of other. Now proof. We are going to write here proof. Now since u1 bar and u2 bar are linearly dependent, and this implies there exist at least one non-zero scalar alpha 1 or alpha 2 such that alpha 1 u1 bar plus alpha 2 u2 bar is equal to 0 bar. Now let us assume that k1 is alpha 1 is not equal to 0. Say alpha 1 is not equal to 0. Now if alpha 1 is not equal to 0, then we can write this equation as alpha u1 bar is equal to minus alpha 2 u2 bar, and from this we can write u1 bar is equal to minus alpha 2 divided by alpha 1 u1 bar, and therefore u2 bar, sorry, here u2 bar, and this implies u1 bar is a multiple of u1 bar is what is multiple of other, u1 bar is multiple of u2 bar. Now we are going to prove here sufficient part, and hence the proof. This is what we prove here. Proof. Okay, necessary part is proof. We write u1 bar is a multiple of u2 bar. Now sufficient part here. Sufficient part. Now we want to prove here, that is what is given here. This is what now we are going to prove sufficient part. Now here given u1 bar that is one of the vector, what do we assume here, that one of the vector is multiple of other, one of the vector given one of the vector is multiple of other, Now what is our claim here? We want to prove that u1 bar and u2 bar linearly dependent vector in a vector space V. Linearly dependent vectors in a vector space V. So now again, to prove this, let us assume that u1 bar is multiple of, so let us assume that u1 bar, that is u2 bar, is multiple of, or say u1 bar is multiple of u2 bar. Say u1 bar is multiple of u2 bar. That is u1 bar is equal to say k times u2 bar. Okay, so we can write this as u1 bar minus k times u2 bar. Okay, so what is the coefficient of u1 bar here? Now if you compare this with alpha 1 u1 bar plus alpha 2 u2 bar, if you compare this, okay, so if we compare this, we get alpha 1 is equal to what? 1, which is not equal to 0. Now since coefficient of u1 bar, that is I am highlighting here, say what is coefficient of u1 bar, we write the given equation as a alpha 1 u1 bar plus alpha 2 u2 bar is equal to 0 bar. But what is the coefficient of u1 bar, which is equal to what? Non-zero. The coefficient of u1 bar is 1, which is not equal to 0, and therefore u1 bar, and therefore since by using definition u1 bar and u2 bar linearly, this implies, okay, from this we can write this implies and this implies linearly dependent, and hence the proof that